This is a video on using the epsilon delta definition of the limit. The question is, use the epsilon delta definition of the limit to prove that the limit as x approaches 5 of 3x minus 9 is equal to 6. So we start out by remembering the definition, and the definition states, given epsilon greater than 0, there is a delta greater than 0, such that if the absolute value of x minus c is less than delta, then the absolute value of f of x minus L is less than epsilon. So pretty much what we need to do is we need to find our delta in terms of epsilon. So we start out by noticing here c is 5. So we want to say that if x minus 5 is less than delta, then f of x, which is 3x minus 9, minus L, which is 6, is supposed to be less than epsilon. So I'm going to start with a little scratch work, and I'm going to look at this f of x minus L is less than epsilon. So f of x minus L is 3x minus 9 minus 6. Do the arithmetic, and I got 3x minus 15. Next, I can factor out a 3, and I can pull that out of the absolute value sign to get 3 times x minus 5. And that's what I want, because I need an x minus c. c is 5, and there's my x minus 5. So what I can say is that 3 times x minus c is less than epsilon, so that x minus c is less than epsilon over 3, just dividing 3 on both sides. And now we have it to look like our x minus c is less than delta, so I'm going to choose delta to be epsilon over 3. So here's our proof, now that we've done our scratch work. Proofs always start the same for epsilon delta. We write, let epsilon be greater than 0. Now we choose our delta, and we've already decided with all the scratch work, we're going to choose our delta to be equal to epsilon over 3. And now what I'm going to do is work my way backwards from here. So in particular, we can say that if x minus c is less than delta, then, well, c, remember, was 5, and delta is epsilon over 3, so x minus 5 in absolute values is less than epsilon over 3. And again, I'm going to do the algebra backwards. Multiply 3 on both sides, and I get 3 times the absolute value of x minus 5 is less than epsilon. Then multiply the 3 through, and I get 3x minus 15 in absolutes is less than epsilon. Then I can turn the 15 into a negative 9 minus 6. And I get that the absolute value of 3x minus 9 minus 6 is less than epsilon. Well, 3x minus 9 was f of x, and 6 is L. So finally, I can say that the absolute value of f of x minus L is less than epsilon. And that's my goal in the epsilon delta proof. So I have now proven the limit really is equal to 6. And I'm done with the problem.